morning again. Good morning again to everyone. This is Vittoria Luda from UNITAR, the Sustainable Cycle Program. I'm very, very happy to welcome you all in today's Strike Project webinar. This is our 8th webinar. Many of you have attended already a number of other either trainings or webinars of this project. We're very happy that you're following us. We're very happy to see many colleagues and friends of Strike and of our team. Today, we're going to be talking about very specific issues related to e-waste. We have a panel of 3 experts together with me that are going to talk about why e-waste is why it's important to really understand statistics and quantify the volume. So compared to other webinars or other trainings of Strike, we're going to be giving here very specific and detailed information about the quantification issues. So maybe I could start sharing my screen, and please let me know if you can see it. I hope, yeah, that is working. I would like to invite, please, all of you to be muted while we are going to have our webinar. You can use the chat. You're most welcome to please include your comments and your questions. There will be question time after each presentation. And the webinar is being recorded, as you can see. So you're able then to have access to the presentations and the recordings after this webinar. So without any further ado, let's start. Maybe I take out my camera just to not take too much band. So the Strike project. So first of all, let's see if I'm able to move the slides. Yeah. So the agenda for today is a brief introduction on the Strike project and why we're focusing on e-waste. Then I will pass on the floor to my colleague, Dr. Kesbalde, from UNITAR Sustainable Cycle Program, who will give us an overview of the e-waste monitors that UNITAR or Cycle has been in charge of and why quantification is useful. And then I'm happy to have Dr. Kathleen McMahon from the University of Limerick that will guide us through quantifying used electric and electronic equipments and waste coming from Ireland. And then Dr. Yvonne Ryan from the University of Limerick, who's also the coordinator of the Strike project and who will lead us into quantifying e-waste in scrap metals. So this is a very interesting and very focused topic we're talking about today. So first of all, let me just briefly tell you about the Strike project. As you know, it's a EC-funded project under the funding for police. It's coming to the end at the end of mid of February, so in a few weeks, unfortunately. The title is Stronger Training and Increased Knowledge for Better Enforcement Against Waste and Mercury. So the topic has been for this project enforcement and support to the authorities. We have 5 partners. The University of Limerick, who's leading this project, and my colleague, Dr. Yvonne Ryan, in particular, is the coordinator, the German Police University, the Dutch National Forensic Institute, and UNITAR, which is the office I'm happy to represent. We have also 5 associate partners, the German Customs Authority, the Environmental Inspectorate of the District of Lower Bavaria in Germany, the Basel Convention Regional Center based in Slovakia, and the African Institute based in South Africa, and also the Waste Management Department of the Ministry of Environment and Physical Planning of Macedonia. So the scope of this project has been the EU, but not only Central and Eastern Europe and the Balkans and selected African countries. So I mentioned about the objectives, the operational activities, the support to authorities involved in illegal trade and management of specific and problematic waste streams, And we have focused throughout the project on a number of what we call problematic waste streams. Today we're talking about e-waste, but we have focused on batteries, on mercury and mercury added products, and end-of-life vehicles and so on. Three main pillars of this project: to enhance knowledge and risk analysis, to develop new tools and methodologies, and then capacity buildings and skill acquisition. And this first pillar, to knowledge, we have produced, and you can find on our website, dedicated, let's say, deliverables or tools to really support the understanding and practical approach to problematic waste streams in order to improve risk analysis and harmonize enforcement strategies and plans. We have developed a strategic risk analysis. We will see some data related to e-waste later on. We have developed a compendium of best practices in planning enforcement strategies, and then we have also developed a short guideline to prepare annual plans and enforcement strategies. I'm sure some of you present today will have already attended or supported this work of Strike in these different components. Another very important part was really dedicated to mercury. And I'm happy to see also in the room some of the colleagues who have this very specific expertise on mercury and that have supported our work. We have in particular worked on forensic tools for the detection and investigation on mercury crime. You can see here we have in particular on-site detection of mercury, and then impact on non-mercury, non-regulated mercury emissions, and then estimations of damages caused by mercury. You can find all of this also on our web page. And in case, just reach out to us, we'll provide you with the materials. And then capacity building, of course, we know that some of these topics related to problematic waste streams can be very practical, can be also very technical. So we have carried out a number of activities aimed at producing specific training tools and materials, a trainer manual, a participants book for our training sessions, and then definitely a number of webinars as the one we're having today. So far we have had 3 online trainings. Of course, Strike actually started and was born along with the global pandemic, unfortunately, because we launched our activity in February 2020 and it reaches an end in February 2022. So unfortunately, we're not in the position to have any physical meeting or training, but on the other hand, through the online sessions, we managed to reach out to more people in different countries. We had, so 4 trainings, 3 have been organized already, led by Germany in October, by Slovakia in November, and the Netherlands very early December. And then we're having the next one, you can see here, led by Ireland and University of Limerick, 25 to 27 of January 2022. So you can find information on how to register in case you are still willing to take part into the last training. Yeah, you can find information about us on the Strike web page. There are newsletters also that give a bit more information of the tools that I briefly mentioned in our previous slides. I will also call your attention. We're going to have the final conference of this project on 9th of February 2022. It will be online again. We'll also invite and have external speakers external to the project, and in particular from our other 2, let's say, sisters project funded by the same funding for police, Ambitus and Opfer Waste. And so we're going to also try and expand on what we have done and what needs to be done on how to, the legacy and way forward after this experience. And also, of course, we would like to collect views and inputs from practitioners and experts in this domain. So you are kindly all invited to our conference. We'll circulate the save the date and all of that soon. Just quickly, we have had a number of webinars already. on different topics. And you can see in the slide here on mercury, on identifying mercury waste and other products, on trending waste and chemicals, and getting very specific information. You can find all of this on the website. It's password restricted, but you can write to us and get access. So you find all of the presentation. You will find the presentation of this webinar too. The same goes for the training materials that were developed and for the presentation of the different training courses we have held in the past and we are going to be having at the end of this month. So just have a look at our website or reach out back to us in case you need support in finding what you're looking for. So now coming to the topic of e-waste. We call it problematic waste stream. E-waste, what is it? It's what stems out of used and no more functioning electric and electronic equipment. You can see from the slide, it can be all sorts of equipment, from, of course, mobile phones or cameras, but also refrigerants, small household appliance, and there are 6 categories, but my colleagues after me will guide us through in what different types of wastes, e-waste. Here I see the categories that are, let's say, covered by this specific waste stream. So is it this type of waste stream, as most of you will know, represent a major challenge in terms of course, when this type of e-waste is illegally trafficked, which means when it is trafficked against the international and European rules related to hazardous waste. So it can be polluting, it can be harmful for the environment, it can be definitely very harmful for people if it is treated in a not healthy and not environmentally sound manner. But also, we also need to say that when e-waste is not well treated or is just discarded, we are also losing a lot of very important and precious materials, because as you can see in the right side of our slide, e-waste has a number of different elements that are very precious and are definitely important to be not to be lost. And I'm sure that my colleague Dr. Balde afterwards will guide us through this. So just briefly on the results of the strategic risk analysis carried out by Strike in the first part of the project, related really to this specific waste streams. We have collected a number of questionnaires, 57 from different countries, 39 countries. I'm sure that some of the people present in the room were also involved in this data collection, which was, let's say, also complemented by specific experts interviews from authorities and experts in the compliance and enforcement chain. Exactly, we looked at looking at e-waste. We have a number of routes that were most reported, and also some very, very already known, like the ones from linking Europe to Western Africa, or from Western to Eastern Europe. So either going south or going east in a way, and top countries mentioned by respondents to our questionnaires and interviews, where in the African continent and West Africa, Nigeria, Senegal, and Ghana. And then when it comes to Eastern Europe, Poland, the Czech Republic, but then Bulgaria and Romania as well. And then going still Eastern, also other countries in Central Europe. It was also reported that experts noted an increase In other countries, specifically to Liberia and Gambia, where the estimates and numbers of e-waste detected, illegal e-waste detected had increased. We also had some examples from other destinations, other regions. Usual modus operandi, it's for this type of waste stream is very similar to other waste streams. So false declaration. So this waste is exported as used electronic equipment while it's no longer functioning. So misdeclaration very often is mixed with household waste. And then a new reported modus operandi is also the exporting of this type of waste as secondhand and charity to textile recycled wood and would export it abroad. So again, this false declaration and misuse of exports. We also had a very specific question related to organized crime groups involvement, and there were a few respondents who mentioned that there was organized crime groups, so organized group of criminals were involved in this, specifically with e-waste, and they were respondents from Afghanistan, Germany, and the United Kingdom. So we have selected indication that some of these exports might also be managed by, or have been managed in specific cases by organized crime groups. So here you see basically the overall numbers. I think of the questionnaires and the detection in different years. As the slides will be distributed, I'll just leave it to you because I see that we have then the important speakers after me. I like to leave the floor to them. We also looked at the trends and risks, and we looked at the routes. So you see in green, the dots are the destination countries that were reported by our within our risk analysis, and the red would be the red dots are the departing countries, and then also transit. So we had a bit of an idea of the flows, which I reported just briefly before. This leads us to say why we decided today to talk about e-waste, electronic e-waste, because we believe that this is a very important topic. It's an important waste stream, and we know that it's very useful to really have an accurate pictures on the data, on the quantities, to better tailor our enforcement plans and capacities and be able to get a sense of this specific waste stream flows. So without any further ado, I would actually like to invite my colleague, Dr. Kees Balde, to guide us through the quantification, why quantification of e-waste is important and what we can learn from this. So Kees, over to you, and thank you very much for presenting today.
Thank you, Victoria, and also welcome from my side. And I'm very glad that we have so many people in the audience. Can you all hear me clearly and see my presentation? If I hear nothing, I continue, and I think it's all fine. Okay, great. Well, I think we all know that measurement of electronic waste or e-waste it's very complex, and this is because that the nature of the products have changed significantly, like over time, first of all, and secondly also the size and the material compositions of these equipment have also changed dramatically in the past century, and also and these changes are more rapidly happening. Understanding this is, of course, very important, because as was explained by Victoria, there are severe issues with the waste management. However, also from a political point of view, we also need these materials which are inside the waste, because they contain a lot of valuable materials, and materials which are which are critical in the supply. And it would be much better if we get them from our waste, instead of having to mine them in geopolitically maybe sometimes not stable countries. And we need also these materials for the upcoming transitions that we are facing, and in particular that we are getting more and more digitized, and secondly that we also need to change the way how we are consuming energy, and it has to become more coming from renewable sources, and we need the same materials which are embedded in our e-waste. So therefore it's very important to measure electronic waste, because measurement is the start of the managing it. We have developed a methodology, maybe a few slides on this, so you have a better understanding what it can be doing, based on 54 different products. Each product has a on average unit weight, so you can convert really easily between pieces and the tonnages. We also have a profile per product. What are the hazardous and the valuable materials, which allows you to also better, like assess the risk associated with this, and the lifespan profiles. So we have that for 54 products for each country in the world. So basically, like what it looks like, that we have a time series of how many products are placed on the market, which we can calculate through statistical procedures. We have lifespans, so we know after a certain like product has been placed on the market, which share is discarded after which year, and we have those lifespans for 54 different products. And as you can see, the lifespan of an air conditioner is longer than of a laptop, and we have that for all of those 54 different products. And with that, we can calculate how much e-waste is generated over time. Well, if we do this for the entire world, for all countries in the world, so we have gathered all of the statistical data from all the from all the countries. We have lifespans from the European Union, and then we can calculate how much e-waste is out there. And the findings are published in the Global E-Waste Monitor. And each year around 7.3 kilogram per inhabitant of e-waste is generated, and this is a rapid growing waste stream. Like 10 years ago, it was only 5.3, and in total, this is approximately 50 million metric tons of e-waste. So more than the weight of the Chinese wall of e-waste is being generated each year. It's also rapidly growing, and we think it will be growing more in the future. The positive thing is that there is some recycling of e-waste in the world, and there is a growth. However, the growth, as you can see in this figure, of the recycling of e-waste is it's much smaller than the growth of the generation. So there is recycling, yes, but it is first of all, it is not sufficient, it's not adequate, and we are currently losing the battle of e-waste. So the amount of mismanaged e-waste is growing every year, and currently we are only at a collection rate at global level of 17%. So the vast majority of e-waste is mismanaged. And I will show a bit more about that in the next slides. In order to have more insight on this mismanagement, and also on the statistics, we do also some regional e-waste monitors. This year we will, in 2 weeks time, we will publish the one on Latin America, and last month we have published 2 monitors on the Arab states and on the CIS and plus Georgia. And in these monitors, we have assessed the statistics, so how much e-waste is out there and how much e-waste is being collected. And we've also assessed the framework of the legislation and the e-waste management infrastructure. And we compare that with the European Union. It wouldn't surprise you that in terms of the legislation, the European Union has basically legislated the majority or all of the aspects that need to be legislated. And there is on the e-waste management infrastructure. However, the collection rate within the European Union is still 50%, so 50. So despite having the legislation and the infrastructure, we are still only capturing 50%. In the CIS countries, some countries have legislation, but the vast majority of the countries don't have a legislation to adequately manage e-waste. And same is true for the Latin American countries and for the Arab region. Next to that, also the management infrastructure is less developed. So basically, some e-waste is collected in cities, and then only mostly focusing at the ones that might contain value, and the vast majority is managed by the informal sector, or also moved transboundary. The consequence is that they have like less legislation and infrastructure, that the collection rates are very low. So on average, it's below 5%. In some regions, I think in the Arab region, it is even lower than 1%. So the vast majority of e-waste is being dumped, and we don't know, and it's not managed in a sound manner. And on the positive side, well, the amount of e-waste that they are generating is still less than what we are generating in the European Union. However, as mentioned earlier, this will grow in the future. A few final slides about one country study that we have done in the Netherlands together with Recycle. So now it's Stichting Open in the Netherlands, where we had a close look what's happening at national level. We used a similar methodology, so we have the monitoring for all those 54 different products, and in the Netherlands, approximately 50%, so half of the total amount of e-waste is ending up at compliant recycling facilities, even despite having a decades-long of systems set up. And the waste collection is happening at supermarkets, at municipalities, in stores, but still only 50% of this e-waste is ending up at the right place and going for compliant recycling. One of the other findings of the study is that approximately a quarter of the e-waste is being managed within the country. So it's not being shipped to another country. It's managed within the country, and it's most likely mixed with another type of waste, so mixed with metal scrap, for instance. And this is not according to the law, and this is not a good procedure, because most of the valuable materials are not being recovered by this, maybe only a few metals. And this is undesired. And we've also mapped what happens with the remainder of the e-waste. So the remainder, like quarter approximately, is ending up in waste bins. So around 10% is ending up in waste bins, and around 10% is being exported. And the exported like items are either as like illegal waste, or in the form of a second-hand good, which are, and I think you probably know much more about it on the modalities, how that works. So then it will be wasted in another country, and maybe some of these items might be or already wasted at the point of departure. So, and the good thing about this is that we have the whereabouts, or ideas of the whereabouts of all the 54 different products that we have in our in our monitoring framework, which also sort of allows you to sort of estimate and to better understand all the risks which are associated with this. For some of the items, well, the risks are like a lot higher, but they might stay within the country, and you would have to do something different than if the risk is being caused in another country through on export. So therefore, I think that's that these sort of data can or should be able to help you also to better understand like what to do for which particular appliance and how much of those appliances are out there in the market. Yeah, so this brings me to my final slide. So my takeaway messages for today is that it's a fast-growing waste stream. We are currently losing the battle, and that's at the global level. It's because mostly the legislation and the infrastructure is lacking, and in particular for the transboundary movement of e-waste, while the low compliance to the Basel Convention and the low reporting of these waste amounts are very problematic in order to monitor this and to effectively like limit the things that we do not want. And of course, I'm preaching to the converted, maybe, or I'm converted myself. Of course, you also need better monitoring and also better legislation and more e-waste management infrastructure if we want to manage this waste stream better. Thanks a lot, Victoria. I hoped I kept within the time.
Thank you very much, Kees. Very interesting indeed. And definitely also thank you for your takeaway points. I invite participants to write in the chat if they have any question or if they want to raise hand. After this presentation, I'd like to collect some questions because Dr. Balde will need to leave a bit before the end. So if there is any specific question for Kees, please raise it now. And again, the presentation will be shared and will be put online. So raise your hand or include in the chat if you have any specific question or doubt for Kees. And also, we really invite you to go through our website of UNITAR and have a look at the global monitor and of the regional monitors to have the more in-depth explanation by country, by region as well. So while we're waiting for people to, unless there is a burning question and I see a hand raised, please invite in the chat. And in the meantime, I maybe ask Dr. Kathleen McMahon from the University of Limerick. Kate, hello, I can see you. Can you hear us properly? Yes.
Yeah, I can hear you guys. Can you hear me okay?
Yes, we do. So thank you very much. And thank you, Elena, for writing where in the chat where the monitors can be seen. So while we're waiting for other questions for Kees, please, Kate, the floor is yours for your presentation.
Great. Okay, I'll share it now. Okay, can you guys see this here?
Yes, if you can put it in full screen at the moment is, we see it correctly.
Perfect. Okay, so I'm gonna ditch my camera because my Wi-Fi is a little shaky. If I can figure it out. Okay, but just so you guys have my face there. So hi everyone, my name is Kate. I'm a researcher at the University of Limerick, and the project I'm going to talk some about today was on the export of used electrical and electronic equipment from Ireland and trying to ascertain what's leaving the country through where and how it's going. I think these talks go really well together because what I did in Ireland, so this part and part of another part of a study that I did is really similar to a small portion of the study that Kees discussed toward the end there in the Netherlands. Oops. So the project was conducted between my university, which is the University of Limerick, the Irish Environmental Protection Agency, and the Transfrontier Shipment Office, which is part of the Dublin City and County Council. and is the Irish authority that oversees the enforcement and administration of waste shipment regulations for shipments that are crossing the border into or out of Ireland, as well as what's passing through. I think you're all pretty international and from different points in the enforcement chain, so forgive me if I go a little broad and say things that you might already know. So I point out this setup between cooperating organizations because I think that partnership and positive relationships between researchers, authorities, and people working on the ground is really the first most important step in doing a project like mine. Really, without the permissions, the training, the knowledge provided by the Transfrontier Shipment Office, I wouldn't have been able to do any of this research. So I think the first step in conducting this sort of material flow analysis is to establish those positive links between organizations like those you all work for and ourselves as researchers. So I'm going to run through just a little bit of motivation for the project and then the steps we took to conduct the research, then a little on what we found and what conclusions we can draw from it. But really I'll spend most of the time on the process and hopefully explain it in a way that can be adapted and replicated in different places. So our project set out to determine how much used electrical and electronic equipment is exported from Ireland. This sort of material flow analysis is important for a few reasons, and we heard a lot of that context from Case, especially around waste being moved and then generated in places when the regulation is, or they're in less regulated treatment sectors. First, so whether waste electronics slip in with the used or used electronics become waste in their destination country after arrival, e-waste is a significant pollution risk, especially when untreated or treated on sites without pollution preventing infrastructure. The resulting pollution can have serious environmental impacts on local ecosystems and waterways, and then also on the health of the treatment workers and surrounding communities. So I think these risks have really been emphasized in this training. However, it's also important to acknowledge that used electronics that are not waste can have a benefit to communities, providing access to high quality, affordable technology and supporting local economies in destination countries. So it really matters how this stuff is packed, what condition it's in, all of that, to be the difference between positive impact in the second photo and potential negative impacts in the first. So really Ireland needs to have a good understanding of where our materials are going and what those materials are in order to address those concerns and limit our negative impact on environment and the communities that we export equipment to. On top of those things, we have these legislative requirements to handle e-waste properly and to not be shipping e-waste without proper permits and without receiving an infrastructure to treat it properly. On our end, one of these legislative considerations is waste collection targets, in the sense that if something's no longer here because it's been legally exported as used equipment for reuse, it's no longer to be available to be collected and therefore can't contribute to the targets we need to meet for collection of waste at end of life. Our intention with this project was to develop a method with which we can keep track of the quantities of electrical and electronic equipment that are being exported. So we have these really important reasons to understand the flows of materials in general. Prior to this study, we only really had one large piece of academic research to rely on for quantification of used electronics or e-waste flows when we got started. So the Person in the Port project in 2017 quantified flows of electrical and electronic equipment entering 2 ports in Lagos, Nigeria. Outside of this research and cases in the Netherlands, we don't really have much data on what's leaving our origin ports in Europe. We took a few points from this study in order to frame our study for what's being exported from Ireland. So first, the 2017 project identified Ireland as a major contributor to electronics entering Lagos, about 80% of which was determined functional under visual inspection. Ireland's a small country, so if we're sending this much to Lagos, it should be a big consideration for our authorities to keep track of this. Second, this report tells us that the vast majority of electrical and electronic equipment is entering Lagos in roll-on, roll-off vehicle shipments, with very little in containers. So this was confirmed to be true for Ireland by our port officials in the Transfrontier Shipment Office. So that's really our first step in conducting the research. determining where the equipment is and where we should look for it. I just want to take a second here to define the term I'm using, even though it may be clear to some of you already, just in case different terms are used elsewhere, or if some of you are unfamiliar. I'm using the term roll-on, roll-off vehicles to refer to shipments that are driven right onto the ship as a whole, as a whole vehicle, and then driven right back off the ship at the destination. They can be shipped empty as just the vehicle, or very often they're filled with contents, which are sometimes electronics, which is what we're interested in. In our data, these are separated into cars, vans, and trucks in order to use the data to be able to predict what type of vehicle will contain the most electronics, or to be able to make a rough estimate of the amount of electronics in a shipment by counting the vehicles and vehicle types. So at this point, we know what we're looking for, roll-on, roll-off vehicles, and we're able to use the on-the-ground knowledge of our port officials and waste enforcement officers to determine that the Republic of Ireland's main ports, roll-on, roll-off vehicles are processed and exported through this port in Cork in the south of the country, rather than through the port in Dublin, where other types of used equipment are exported, which is more things like business-to-business equipment and semi-processed materials for recycling. We also looked into the business-to-business equipment in a separate study. So this is, oh, yep, that's the port. This is an aerial view of the port we conducted in our sampling. This red is the small, oops. This red is the small secured storage yard where private citizens, that's who's largely exporting these vehicles, can bring their vehicles to be inspected and shipped at designated times. The lot is really well secured because vehicles can't be locked in order for inspections to take place. Myself and my colleague Chidi received special safety training and permissions to enter the lot with the waste enforcement officers over or once a month for a 10-month period. Ideally, we'd have like 12-month period. However, our visits were cut short when COVID made its appearance in Europe, and we entered our first lockdowns in spring 2020. Shipments happen from this lot about every 2 weeks, and official inspections by waste enforcement officers are conducted once a month, so about every other shipment. On any vehicle flagged by port or shipping company employees, and on random selection of present vehicles during the inspections. Yeah, so those ones don't ship. Inspections require access to the vehicle and check that any contents are well packed so as not to be damaged in any way. That they don't collect or contain dangerous or illegal items like e-waste, and that they contain the proper documentation, especially for electronics, that show that equipment is functional and being sent for reuse. These inspections are really important for minimizing the chances that e-waste is being shipped, both to comply with legal requirements, but also to prevent the chance of negative impacts on the environment and the communities that we discussed earlier. So the documents that we looked for in our study include the detailed list of contents, which I'll go over briefly on the next slide, and the electrical declaration, which is required for each piece of electrical and electronic equipment being shipped inside a vehicle, and certifies that a qualified professional tested and signed off on the functionality of each piece of equipment. Vehicles were required to contain these documents, and that the documents are accurate upon inspection for any vehicle that was being shipped with contents. Although the cost of shipping is based on just the vehicle itself and not the weight or nature of the contents, so really filling the vehicle is at no extra cost for the exporters. A decent number of the vehicles we sampled were empty, and therefore they didn't require these documents. Any vehicle that contained items of any kind, furniture, clothes, car parts, which actually require additional paperwork, etc., but did not have a packing list or necessary accompanying certificates, was flagged for inspection and was not shipped until the documents are supplied. While waste enforcement officers conducted their inspections, Chidi and I conducted our own sampling on every vehicle present in the yard on inspection day. Each vehicle was given a unique identifier based on the license plate in order to make sure we didn't count the same vehicle twice on different sampling days. in case the vehicle hadn't been shipped yet or had been placed on hold by inspectors. Like I mentioned before, some vehicles were empty. For any vehicle that had contents, we took photos of the accompanying packing list, checked for electrical declarations, and recorded the contents of the vehicle. Packing lists ask for the type, quantity, and estimated value of the item, as well as whether the required documentation for electronics and car parts are present. You can see here that this one was all electronics. That wasn't the norm, but it's a good example of what it looks like. This person also gave us serial numbers, and the effort put into this packing list indicated to me that these items are probably really going for resale. These are just some of the photos from our sampling days in the yard. You can see, as required by our safety training, that we have on our hard hats and boots and high-vis vests in the inspection yard. You can also see some of the likely contents there. For example, for trucks, we mostly saw car parts or whole vehicles as contents. This document on the left was also useful to us in our sampling, which was from the shipping company and included the destination port. During our period of study, Lagos, Nigeria was the destination for more than 90% of the vehicles shipped. This is pretty reflective of the breakdown of African immigration to Ireland. The exporters were largely people with ties to Nigeria who are familiar with the destination market and are sending the vehicles and contents for both personal use and resale. Along with the examination of the documentation, we also conducted a brief visual inspection of the vehicle to determine that the packing list was accurate. Of course, there's some room for error here. For the most part, you could see that the items reflected the list. Occasionally, we'd come across some e-waste or some equipment that was likely to become waste on the journey due to poor packaging. You can see here these stacked TVs and loose electronics. These wouldn't pass the waste enforcement inspection. The cage on the side here was originally in the yard so that people shipping their vehicles could dispose of their e-waste into official channels on site, but was removed at some point due to, I think, collection or permit issues about having e-waste stored on the property, but I don't quite remember. But in any case, any vehicle that doesn't pass inspection or is placed on hold and isn't shipped, the vehicle then has the opportunity to fix the problem. The vehicle owner has the opportunity to fix the problem. If it wasn't going to be shipped, we didn't count it in our numbers. After sampling, we went home and input the data into an Excel spreadsheet, noting the sampling date, type of vehicle, whether or not it contained electrical and electronic equipment, in what category, and how many were present. We found that cars and vans were much more likely to contain electronics than trucks. And only about 1 in 5 vehicles overall contained electronics. 1 in 4 in cars and vans. 1 in 4 in cars and vans, which is a lot fewer than the ratios of vehicles found coming into Lagos from Ireland in 2017. We think that this is down to increased effective enforcement at the port. And that didn't just come from authorities, but also from the shipping companies themselves. In that period of time, there had been several damaging fires on board cargo ships, very likely attributed to undetected illegal e-waste shipments on board. And even one ship was lost to sinking. So the shipping company has a really solid incentive to help prevent e-waste from getting on board. This is another example of the importance of these partnerships between stakeholders and working together to achieve the same goals from different angles. Waste enforcement officers from the Transfrontier Shipment Office confirmed with us anecdotally that in the months prior to our sampling, they had seen a noticeable and significant decrease in vehicles containing electronics and also in finding e-waste in the inspections. And they attributed some of that to the shipping company cracking down on it as well. We used a set of defined keys from the United Nations University to assign consistent weights to each type of electronic. And that allowed us to go from a number of units to a weight measurement. So for example, flat screens average a particular weight, refrigerators another. And this is a really good way to remain consistent between studies that makes them all comparable with each other in the end. We sampled a total of around 5.5 metric tons of used electrical and electronic equipment. That number, 5.5 metric tons, was then scaled from the sample size we collected to an annual amount based on historical data provided from the shipping company. We did find the shipping company more hesitant than other parties to talk to us, given that we were functioning on behalf of the enforcement that oversees their activities. And we get that a commercial entity can be a little wary or very procedural about these communications. So just another example of the work this type of research needs to put into the effective communication of motives and reassurances with different parties. The annual total ended up being around 17 metric tons, which again is significantly less than was found in 2017. If we look at the person in the port report again, around 80% of the material coming into Lagos was functional on visual inspection, so 20% was waste. Assuming the ratio is the same, that would be around 3.5 metric tons of e-waste annually entering Lagos from Ireland, which of course shouldn't happen, but is relatively low and is likely to be at least a little less with more functioning equipment than before due to inspections and new shipping company rules. In the collection of data, we were also careful to separate items into categories, which was of course important for the weight calculations, but also for further or future analysis into the composition and what component materials are leaving the country and entering Lagos. For example, these two most common categories by weight, refrigerators and flat panel TVs, both have components of concern for pollution and health impacts with coolants and mercury. And the process and infrastructure for treating these items is going to be different in Lagos than it is in Ireland when these items do become waste. So it's important for Ireland to know the breakdown of not only what's leaving, but how many hazardous components are going as well. And important for destination countries to know what's coming in and what the extra requirements would be on the recycling and treatment infrastructures. As a side project, we also did an analysis on what the value of this used equipment would be in the destination market, and therefore sort of an analysis on what some of the motivation for export might be. We did that by using the brand and model of items on packing lists and comparing those items to listings for similar items in Nigeria on online sales websites. We found that there was significant value for exporters in shipping electronics. So remember from what we said before that there's no charge for loading up the shipment vehicle with whatever you might want to sell at the destination. So any of this is value from any of this value from the contents of the vehicle is really pure profit for them. We found that in some cases, the exporter might actually get a higher price in Nigeria than they would for the same item in Ireland. And that's probably due to difference in cultural values toward reuse and used equipment, which can really be unnecessarily stigmatized in Ireland and is usually more valued in developing markets. As well as a demand for European products in Nigeria. Our totals ended up at almost 150,000 euro annually to be earned for the exporters as a whole. So hopefully I've hit on the most key points of how this material flow analysis happened and why it's important. In Ireland, there are a few more things to look into to get a really clear picture of what's being exported. Some we've looked into in other projects. Although this project represents what should be the vast majority of consumer-based electronics being exported from Ireland, with an almost entirely West African destination. And relatively, this doesn't seem to be a significant place that e-waste is going currently from Ireland. We think that this should be a regular quantification, not necessarily annually, but to monitor for changes in behavior and keep track of the material flows. This method should be fairly adaptable, especially across the EU, where regulations are similar, but elsewhere as well. For example, in shipping procedures where the documentation isn't present, the visual inspection would take on a bigger role, although that can definitely be more labor intensive. It would be really great if more countries engaged in origin port quantifications for used equipment and waste equipment to really create a sufficient material flow analysis for use in effective and useful policy and decision making. So thanks everyone for your attention, and I'll pass it back on for any comments or questions.
Thank you very much, Dr. McMahon. I think it was extremely interesting. I think it was also your presentation allowed to bring the quantification and statistics to very concrete inspection actions. And of course, also thank you very much for providing us insights on what would be needed also in the future. And of course, your invite to conduct similar studies and efforts would be very useful. Again, I'd like to invite participants to either pose a question now or put it in the chat. Definitely would be interesting for us to know if other countries represented in the room have conducted similar studies or are collecting similar data with regards to e-waste or the specific waste streams, but definitely e-waste is, as we have seen, very, very important and very interesting. And I will now call our last but not least, our colleague, Dr. Yvonne Ryan, who's project coordinator Strike, an extremely good colleague and friend, to have the last presentation. Yvonne, floor is yours.
Oh, thanks everyone, and it's great to see so many attendees this morning. I know it's hard on a Friday after the Christmas holidays and the break to be motivated to listen to us speak for a while. So I'm going to turn off my camera now because, similar to Kate, when we're all working from home, our broadband tends to dip a little bit. So I'm going to now share my screen, and hopefully you'll be able to see that. Oh gosh, I do not want to leave the meeting. Hopefully you'll be able to see my screen. You might just let me know if you can.
Yes,
so
actually.
Can you see it now? Not yet.
I
Okay.
know. No.
Hang on 1 second. Oh, I see. Your screen. This one. Okay, that should be working now. Okay, brilliant. Okay, my research is similar to Kate. So this kind of originated from a desire in Ireland to get a real handle on wee flows in Ireland, to see where things were going, where they were coming from, what was being lost to leakage, and what could be done about this. So the Irish Environmental Protection Agency and the producer register organisations wanted to quantify e-waste flows in Ireland, and they funded this project called E2We, and so we being waste, electrical and electronic equipment. And they funded this primarily to address the challenges brought about by the recast WE directive, which increases collection targets, and to ensure that Ireland reaches those collection targets. Prior to this, Ireland had a very good compliance rate when collection targets were not based on consumption. However, we consume a lot of electronics in Ireland. Even though we're a small country, our per capita use, or per capita put on market of electronics is actually quite high. The full details of this research are available. I've put the 2 links there, and there's a summary video of the research. So this research was not only a quantitative assessment of wee flows into metal scrap, but there was also a consumer behaviour aspect to the research, which was conducted with colleagues in our business school, and they looked at marketing, consumer behaviour, and attitudes around e-waste disposition and e-waste disposal. And it's a fascinating piece of research. So there's, I'm talking about my colleagues in the KVS, in the business school, because they took a very different approach to this and really got into the psyche of what makes people hold on to items and what encourages them to let those items go, and what encourages them to bring them to an appropriate recycling facility. Okay, so this, we know from previous literature and from previous studies that lots of e-waste that's not collected by the formal e-waste collection schemes or by local authorities for appropriate treatment, we know that this ends up in different terminus points. So if we see here on the left, if a consumer or a business brings their e-waste to to the civic amenity site or to a specialised recycling facility in Ireland, it's treated at a Wheelabex compliant or certified facility. The residual fractions might go to a scrap metal processor, the hazardous materials, other plastics, etc., go onwards for appropriate treatment, but they are depolluted and treated appropriately at a Wheelabex certified facility. However, if a consumer or a business puts e-waste into their waste collection, if they hire a skip, so you know, just for people outside Ireland, skips are those large open collection, you know, for construction and demolition, household clear outs. They tend to be very large. They're delivered on a truck, put on your curbside. You fill it, that company takes it away. So that's a skip. Or if they bring e-waste in scrap metal or stuff directly to a landfill site. This stuff is not treated or depolluted. It's not counted in our statistics, and it goes through various treatments, but they kind of all end up at similar terminus points. So why is this interesting from a waste shipments point of view really is because that Ireland, we don't have a smelting facilities in Ireland basically anymore. So all of our scrap metal is exported. It is put on ships, it's exported. Again, with lots of our hazardous waste it is exported. The danger is that when this waste isn't appropriately depolluted or treated at a Wheelabex collection site, number one, it's not counted in our e-waste statistics. Number two, it poses a hazard to the next person in the chain who encounters that e-waste. So it's incredibly important to know why this happens and where this stuff is going. So just a broader view of why e-waste is problematic in metal scrap. And both Victoria, Keys and Kate touched on so many of these, so I'm going to keep it brief. We need to meet our targets. An economic benefit arises from concealing e-waste from appropriate treatment. So if there are, you know, if a company or a business, consumers in Ireland pay a small surcharge on every piece of electronic equipment, that funds appropriate recycling through the producer register organisations. However, some companies may choose not to do this, and if they collect e-waste and they conceal this from appropriate treatment, there is an economic benefit to them. There's an economic benefit in terms of not sorting waste appropriately on a site, just filling your skip and sending it to wherever your final destination. Sorting waste is expensive. It's manual labor, it's intensive, and it's expensive. E-waste is categorized as hazardous due to its components. Concealed e-waste is a health and safety threat to waste facilities. So just recently, the US EPA published a report on an analysis of lithium-ion battery fires in waste management and recycling. They published this during the last summer. And as you can see, the injury rates, service disruption and monetary losses, and also the calling out of emergency responses and the incidence of those that have happened, it's quite significant. And obviously, at the transport side of things, 8% resulting in injuries to people. I think that's absolutely unacceptable. So we need to protect people. We need to protect, if we're protecting people, we're generally protecting the environment as well. So it's important to consider these aspects. So powered E are the kind of the items that contain lithium-ion batteries, and these are a potential fire risk. But also the circular economy aspects to appropriate e-waste treatment is that it results in job creation. The critical raw material recovery is so important. However, we need to kind of be cognizant that that could become a driver of concealment into the future. But there's so many important aspects to dealing with e-waste that it's important to take the holistic view of that, especially when devising enforcement and inspection plans. So just to give you kind of an overview of the method that we use to determine the quantity of e-waste and metal scrap. So firstly, we kind of employed a very desk-based research. We tried to establish the population size of metal scrap in Ireland. We therefore used data from the National Waste Collection Permit Office. We looked at transfrontier shipments. We also liaised with the Environmental Protection Agency, looking at waste characterization reports, and we looked at EPA licenses and annual environmental reports from scrap metal handlers and from various treatment facilities. We looked to the published literature to develop a method, and if we've published a paper on this in the Journal of Industrial Ecology, which goes very much into the detail of the method development. So if anybody's interested in that, I can point you towards that paper. We consulted then with the Environmental Protection Agency, with regional waste management authorities, particularly the Southern Region Waste Management Authority. There is also a packaging compliance scheme called REPAC, and they had done some similar research, and we consulted with them. We consulted with the reprocessors to see their viewpoint on arising in metal scrap. We also consulted then with metal recyclers, scrap collectors, and tried to bring them on board. And we successfully managed to get 5 sites to come on board and allow us to, not just 5 sites, sorry, 5 companies to allow us to sample on their sites. And as it turned out, some of the sites weren't suitable for data collection. I'll go into that in a few moments. We also consulted with Keys in the United Nations University. I'm so glad that he explained the UNU keys, so I don't have to, but basically, we figured that the UNU keys were incredibly useful to this research. And we also consulted with RAP in the UK, who had also completed a similar type assessment. However, we ended up taking quite a different approach to theirs. So we basically then did on-site consultations with scrap metal facilities. We established a sampling method, the health and safety procedures, the materials required, the data that we'd be able to extract from that approach. We piloted the sampling methods in January and February 2019, and then we conducted the data collection in 2019, and we secured 5 sites that were appropriate for sampling. Okay, so what we observed on scrap metal sites was that scrap metal would come in, it would go over the weighbridge. Now, scrap metal can come in on skips, it can come in on the company may have their own collection vehicles where they would go to a site, remove scrap metal, bring it back to their depot or their terminus for sorting and grading. Or members of the public and other businesses can arrive on site, ask to deposit metal scrap. Their various details about them are recorded. For example, their name, their address, they have to produce ID, and the vehicle registration number is also recorded. So we were able to get this information and use this. So we were on site. We would see as scrap metal inwards arriving, it would be weighed on the weighbridge, and that metal will be tipped, sorted in the yard, and some hazardous materials are removed at that point. Sometimes is removed if it's quite obvious. Mostly I can say it was not. And then also any, extremely valuable materials that are quite obvious are removed for sorting and for further processing. So for example, a copper barrel, a copper pipe, copper barrels, things like that would be quite obvious and would be removed to the copper storage area, things like that. So basically the terminus points of these items. So good scrap, which is good clean scrap iron and metal, that's sent for export and smelting. And bad scrap then is kind of lots of kind of householdy composite kind of metals that would have plastics in with them. They're either shredded here in Ireland or they're sent overseas for further processing and shredding. So from that, we could determine that the list of waste code was a really key way of generating data and statistics on this. So like I said, we recruited scrap metal sites and screened them for suitability. So by screening for suitability, what I mean there is that from that particular site, the waste would be going directly for either shredding or export. We did not survey sites that further transferred these incomings into other kind of statistics. So it was first arisals of waste, then going for it cascading down to either export or shredding. So, and also the sites had to have enough room for the survey to be conducted, and also be safe for the researchers to conduct this kind of research. They're kind of very busy sites. There's lots going on. You have to have good sight lines to make sure that you're not going to be hit by moving vehicles on site, etc. So that was kind of the approach that we took in making sure that those sites were suitable. We then determined that there was 2 admissible list of waste codes that we were going to look at. And this was from the point of view that these were first arisals of waste. So they hadn't been processed elsewhere before arriving on site. They had come directly from the site in which they've been collected. And that these were the most populous. So you would see these on site every single day. Some list of waste codes are occasional. And if a researcher was to sit on site waiting for those codes to arise, you could be sitting there for a month before you'd get one load perhaps that would actually be surveyable. And it would be almost impossible to get a statistically representative sample. So these were, the quantity of these was sufficient to gain a statistically representative sample. And then we developed the database using the 54 UNU codes, which Keith has explained already. And we were able then to count items and derive a mass based on the count from those UNU codes. So this is the kind of data collection conditions on site. So materials being tipped and being sorted by the grab. This kind of tends to be what the scrap pile looks like, and you can actually see some wee in that scrap pile already. I can see washing machines straight off. So basically, stuff arrives on site. It's spread around. The researchers counted the number of wee items observed in that particular load and recorded those. So ultimately, we found that between the 2 lists of waste codes, scaling upwards, around 10,000 tons of e-waste is expected in metal scrap. And the category where the large we are expected were construction and demolition, home renovations, that kind of thing. So if you look at the type of items we saw, so this is the mass-based count. We saw a lot of washing machines, central heating, so boilers, kitchen appliances, household heating and ventilation. professional IT. So this goes back to, again, what the nature of these two lists of waste codes were. So 1705, so if we go back one slide, 2 slides, 1705 is iron and steel arising from construction and demolition waste. And 2140 is kind of home renovation stuff, skips from domestic sources and things like that. And so it kind of makes sense. The objects observed were what you would expect to arise in skips and from construction and demolition. When we look at the count-based, lighting and lamps were quite significant, found in significant quantities. Again, central heating dominating and household heating and ventilation dominating the count-based items. But sorry, just go back. The kind of interesting one for me is the household luminaires and lighting, and also the professional IT equipment. When we count smaller items, we can see items that are critical for hazardous waste prevention, but also in terms of recovery of those critical raw materials. And this is because a lot of the critical raw materials are in smaller items. And the loss of these smaller items to scrap metal and things like that, while they don't show up, flag as a quantity issue, as a mass issue, they should be counted as a significant loss in terms of the circular economy and recovering critical raw materials. So that is a really a useful use of those UNU codes in counting that the specifics of the WEEE arising in metal scrap is so important. So a summary of the key findings and the implications for policymakers and waste enforcement from this research would be that construction and demolition poses a significant risk in the loss of WEEE items, particularly to metal scrap and other waste streams. And one of the reasons for this is who has responsibility for this end of life e-waste. Is it the property owner? Is it the leaseholder? Is it the construction firm? And you know, the waste management plans for the construction and demolition sector have not adequately grasped this nettle, really. There's very little in the guidance for construction and demolition. Bringing waste management plans for the construction and demolition sector has focused on kind of the headline hazardous items, such as asbestos in particular, but not really seeing e-waste as the hazard that it is. And also in terms of ownership, if it's a leased property and the person who had held the previous lease has left e-waste, it's impossible to chase these people up and get them to take it back. What we did see was no evidence of deliberate concealment of e-waste in metal scrap. I think a lot of this e-waste arising in metal scrap is kind of accidental and arrives really from a point of ignorance rather than deliberate concealment of e-waste. From this research, we found significant opportunities to improve access to civic communities, improve the convenience of recycling, particularly for e-waste. Our research overall made a number of key recommendations, both from the metal scrap perspective to end that kind of trickle into that stream, but also from the consumer behavior side. And access to civic communities, convenience is a huge driver of compliance. The recovery of e-waste at scrap metal sites has been improved, and because it's not deliberate concealment of e-waste, I think there was great opportunity there for the scrap metal sites themselves to liaise with the enforcement agencies and with the producer register organizations to in some way broker a way to get this e-waste out of the scrap metal when it arrives at the site. There should be better guidelines for construction and demolition activities. The waste management plans are a key point in this. And also for construction and demolition workers, they should be aware that e-waste is a hazardous waste, and they should be protected from any ill effects of handling e-waste as part of their job. And it's interesting that because of the recast redirective, professional e-waste has now come into scope, and we saw a lot of professional e-waste that came into scrap metal sites because of renovation of commercial properties. And this is another aspect that needs to be addressed in tackling these outside of compliant collection flows. So thank you everyone for your attention during my presentation, and of course I'm always available for questions. This is my email address, yvonne.ryan@ul.ie. I've pointed to a report and a video in my presentation, and I also spoke about a journal paper that we published, and I'll put a link to the journal paper in the chat after this. I just realized that I hadn't put a link to it within the presentation, and I'm very happy to field questions on this research directly after this slide.
Thank you very much, Yvonne. There was a question actually for Kate in the chat. Kate, I think you have replied to Michael. Would you like to first take it up just quickly, and then if there are other questions for Yvonne? I'm also conscious about the time, of course, I know, and I'm happy that all of you managed to stay on board until this time of the day. But yeah, Kate, if you want to take or maybe elaborate on your reply to Michael, and then if there are any questions for Yvonne. Thank you very much.
Hi everyone. So Michael had asked in the chat, based on the study, if we think that the person in the port study, if they repeated it in Lagos, that if Ireland would still be number 8 in the ranking of we entering Ireland. And I do think that the rankings would end up pretty different if it was done again. And a lot of that is based down to just the improvements in an effective enforcement in Ireland. So partially from the shipping company and partially from the controls that have been put in place. I also think that the number originally was very high for a country as small as Ireland. It was a number of kilograms per person. So I think that, you know, in scaling, sometimes when you're scaling the same country as big as Germany and as Ireland, that the scales get a little mixed up too. So I think that the numbers would rank differently now.
Thank you very much, Kathleen. Any question for Yvonne? And I also would like to flag that we have another webinar coming up next week. It's on the road inspections. So it will be actually dedicated only to law enforcement officials. So it's restricted, but as you see in the room, there are some practitioners with us. And if you're interested in having case studies from, particularly from the Federal Police of Belgium on road inspections, you can sign in for that one. It will be next week on Wednesday. My colleague Elena can put maybe the registration form in the chat. Thank you very much, Elena. I see you have done so. Still a couple more minutes for questions for Yvonne or for any of us. Thank you, Yvonne, for also putting the link to the paper you were referring to just earlier. And And if there aren't any specific questions at the moment, feel free to refer back to us. You will have the presentations and just write to us if you have any questions, and look at our website. We look forward to continue discussions with experts from different countries and from different regions. And thank you very, very much for attending our webinar today. And yeah, stay tuned. 9th of February, we have our final conference too. So we hope to see many of you on that occasion online again. Thank you so much. Thank you very much to our speakers, Dr. McMahon, Dr. Ryan, Dr. Balde, and all the best to all of you. And thank you very much for being with us today, and have a nice remainder of the day and weekend. Thank you very much.
Thank you, everyone.
Thank you.
Thank you.
Thank
Bye-bye.
you. Bye.